For those of you that have just tuned in, my name is Tony Terrell. I'm a technical marketing manager here at TechSoft 3D. And today we're going to be talking a little bit about data translation in the Hoops web platform. The goal of today's virtual training is to truly be that kind of a training, actually get your guys' hands wet with data translation tools that we provide to you. So if you are planning on following along, you should have received some instructions maybe earlier this week. If you want to follow along but did not know that, feel free to go look through your email. I'm going to churn through a couple of slides here at the beginning to kind of introduce us to the topics, and then we'll actually start the hands-on demo stuff. Some other things worth noting for the demonstration, I'm using our Windows distribution. So if you have downloaded our Linux-based distributions, I'm trusting that you are capable of doing the necessary changes between Linux and Windows to get it working. If not, feel free to throw some questions in the chat room, and we can kind of maybe answer those as we go along, or maybe Jonathan can help you troubleshoot those while I'm going through the slides. So we're encouraging you to follow along, but like I said earlier, if you want to sit back, drink some coffee, and just kind of get your morning kicked off, feel free to do that. So before we start diving into the data translation, let's just bring everybody up to speed on what we here at TechSoft mean when we're referring to the Hoops web platform. And that is going to be our product Hoops Communicator. So Hoops Communicator is basically comprised of a couple different pieces of software. The first of which goes by the name Streamcache Server, and the second of which is the Hoops Web Viewer, and then finally Hoops Converter. So these three pieces of software are kind of in charge of three different stages of the pipeline. When you put them all together, you get a picture that looks something like this. It's basically, you get Hoops Converter taking 3D CAD data and converting it into TechSoft's proprietary file streaming format. There's also a couple different file types that solve different needs that we can convert to. But this is kind of the first step, and the one that we're going to be focusing on the most today. How do we get your 3D data into a format that is usable within our environment, and how do you get the most value out of that data when you're converting it? So after you've converted your data, you're going to send it into your client's web browser through our SC server. The SC stands for Streamcache. That is kind of the go-to name for our proprietary file format. So when you see SC, you can just think Streamcache. And then once the data makes its way into the client's web browser, that's where the Hoops Web Viewer is actually going to take care of the visualization. And that's kind of, where everything comes together. That Hoops Web Viewer is just kind of like a JavaScript WebAssembly solution that gives you the high performance visualization that you would expect from like our Hoops native solution, Hoops Visualize, but targeting cloud and mobile. So that's kind of how the pipeline looks. Let's focus in on this converter thing that I keep talking about, and just talk a little bit about, what it is. I know maybe some of you are familiar with Communicator. I don't know how many people have actually gotten their hands on Converter though. So we're excited to be talking to you about this today. At its base level, Converter is essentially a piece of software that converts 3D CAD models and also 2D CAD models, into, like I said, our Streamcache format. The Streamcache format is going to allow for this CAD data to be loaded via WebSockets into the client's web browser, where it can then be visualized and interacted with. In addition, to converting to our Streamcache format, this Hoops Converter piece of software that comes in the Hoops Communicator distribution is also going to allow you to convert your CAD data into a couple different formats. Like you can export pictures. If you license Hoops Publish, you can export your data to 3D PDF. I believe that there's like an ISO standard PRC export, and a couple other ones like that. So there's definitely other options with Converter than just bringing it into our format. It might be able to solve some other issues for you as well. So for the purpose of today, Converter can essentially be thought of as an executable program that lives within the Hoops distribution that you have downloaded. You're going to find it within that distribution at the following path down in the authoring folder. I will note that that path is different based on what platform, if you downloaded it for Windows or if you downloaded it for Linux. So on our website, we have kind of an introduction to, like, what does this do? We kind of have some of the CLI arguments and stuff documented out. I realize that you guys are unable to click on these links. However, they are for me to click on. I'm going to go ahead and throw this one just down into the chat, and we will see. Maybe I will. I'll just throw this link in there in case anybody wants to pull this up. We're going to be referencing some of these command line options later. There's some important ones in here that I plan to touch on. If there's any in here that you're looking over that you want to know more about, please let me know, but I don't want to bore you guys by just reading through the docs on our website. So the other things that I will note about this converter, we're going to be using an executable program today. We do also distribute C++ library files for these in case you would like to integrate this conversion functionality directly into your application, right? And then we also ship all the dependencies, obviously, so that it's easy to run. But this also means that you can pretty easily bundle this application up into your favorite container technology, whether it's Docker or Kubernetes or whatever. So that's a little bit more of an advanced topic for a different time. But if you are into that sort of stuff, you can go crazy with it. So that is, in a nutshell, Converter. That's kind of intro to it. So let's take a look at what Converter actually allows us to do. For those of you that are planning on following along, before we get started here, I'm going to have you do a couple things just to get your distribution up to date with mine. If you can, just open up a file explorer or a command line or whatever you want into the installation directory. And there you're going to find this list of folders. There's only about 2 folders that we're interested in today, and they are the authoring and a quick start. The quick start is going to kind of serve as our working directory for everything that we're doing today. And if you have CAD data that you would like to try to translate and convert, don't worry about this step. If you do not have any CAD models, I'm going to ask that you go into the authoring converter example data directory. And today I will be using the Garrett support bar 4 CATIA part, as well as the Modo directory. And I'll be pasting my commands that I'm going to be running with these file names in the chat. So if you're just trying to follow along word for word, going and getting these 2 models would probably be the easiest way to do so. So after you've grabbed these, we're going to want to drop them here into the quick start directory where we're going to be working from today. I would also go ahead and open up a command line prompt here in this directory as well. I'm using my favorite flavor of Git Bash, but you guys can use whatever you need or whatever you would like to use as well. So you have your data here. The only other big thing, and I think this is going to work, is going to be a license. If you've downloaded this in the past, day or so, your license should be good for, I believe, 90 days. But in the interest of following along directly word for word, I have placed my license in this license file, just like this plain text file. You can find your license in the server config.js, I believe at line 278. So you can either copy that into your own license file, or if this works, I was going to try to upload this into the chat and then just have you guys take this license. But it seems that I am unable to share a file. So we will work around that. Dang it, I was going to give you guys the commands too. Oh well, I will just have to paste them in the chat as we go instead of giving you the file containing them all. Okay, so you've got your data here, you've got everything else set up. So all we're going to do for this little intro demo to converter is we want to take the model that we want to convert, the Garrett support bar, and we're going to drop it on this convert file.bat script. Oh, that's unfortunate. It doesn't like that license file. Okay. I apologize, everybody. I'm going to have to stop sharing this really quickly while I change my license so I don't give anything away.
While you're doing that, Tony, hey, Jonathan here again, everyone. Could I just see a show of hands of who intends to follow along? I know, Paul, you already signed up, but I'm just curious, as we kind of walk through different things, if there's anyone else who's kind of going step for step with Tony today.
It might help me kind of gauge the pacing a little bit for.
So you could open up the participants or the chat window and either raise your hand or give a checkbox yes. I'm curious to see who's following along with it today. All right, thanks for that.
Okay, I apologize for that, everybody. Let me go ahead and reshare this and make sure I have my license hidden. We're going to share everything. Okay, we are back and we're in action. Okay, so as I was saying, all I'm doing is I'm dragging this CATIA part onto this convert file batch script that's going to go ahead, and it has a good license now. So it's going to, what you're basically seeing here is you're seeing the output from that converter executable. Oh shoot, I forgot to tell you guys one thing. You have to launch this, run this start server batch script as well. I apologize for that. So once you've launched that start server script, that's going to run that stream cache server component in the background. Dropping that file onto that batch script is basically going to run it through the converter exe with a pretty standardized conversion. And then what you're seeing here is you're seeing this little support bar loaded in the Hoops web viewer in our browser. And here you can see it has like some PMI data with it that's being rendered as well. So this is just a really kind of quick and simple conversion. If you go into your installation directory, you can actually see the converted file down in Quick Start Converted Model User SC Models. This is an important location. This is where all converted files need to be stored in order for them to be accessed by this little quick access application that we have here in the browser. I need to pull the chat up really quick. I apologize. Maybe it has disappeared on me. Oh well. Okay. I don't like it. Jonathan, do you know? I'm sorry, guys. Do you know how I get the chat up? I'm trying to figure out.
Yeah, if you go to your control bar down at the bottom, there should be a button that says chat. You might have to hit escape to kind of minimize the Zoom meeting just a little bit. Sometimes there's also an ellipsis, a ... that allows you to kind of go into the chat window.
No. Oh well. Okay. Could you do me a favor and just relay anything that you see in there that's too important? or that's important. Oh, never mind. I got it now. It's hidden because of presentation. Okay, sweet. Sorry, everybody. All right, getting back to where we were. So we've drugged that. We've drugged that on there. I've shown you the converted location that we're at. So that CATIA part has been now turned into a .scz file. This is one of the file formats used within the Hoops web platform. So I'd like to peel back a couple of the layers around the file types that we're going to be seeing and the file types you can convert to. So we right there had a .scz. There are a few other file types used by Hoops Communicator, the first of which is a .scs file. This is a stream cache single file. This is kind of a monolithic file type in the sense that all of the information needed or all of the information surrounding your CAD model that you're converting is stored here. This file type is not streamable, so it is not compatible with our stream cache server. And this solution is usually used when the file is being served by like an HTTP file server or just being served from the local file system. So obviously you're not streaming it in, the performance is a little bit different. It's kind of a completely separate use case. Today we're going to be focusing mostly on the streaming file formats, the first of which is an SC directory. The SC directory is a streamable file format. It is uncompressed and is non-compressible. And the SC directory format is very similar content-wise to the SCZ file format like we just used and converted to. The only difference is the SCZ is essentially a zipped up directory, a zipped up SC directory. I will note that it is not zipped up using like WinZip or 7-zip or something. So don't try to create an SC directory and then just zip it up and rename it yourself. One of the other cool things about the SCZs, and I think that makes it kind of the more popular file type with Hoops Communicator, is that these file types can be compressed. They do not have to be compressed, but that is up to you and what you were trying to get out of it. So these are kind of the three file types. There's SCS, stream cache single, SC directory, and then there is SCZ, both compressed and uncompressed. So what I'd like to do now is look at how you use Converter to create these different file types. And then after we've created them, I want to load them in there and show you guys what they look like. So the first one that we're going to be creating is a stream cache single file. Just notice that we're going to be essentially invoking the converter executable at the platform of your distribution. The working directory for this command is going to be the quick start directory. We're going to give it that license file that I have. We're inputting that CATIA part, and all that we're doing to convert to a stream cache single is just asking it output. I can't click output stream cache single, and then we have to give it the name. So I have my little cheat sheet here that I'm going to pull up. I'm going to pull it over here, and let's go ahead and let's create a stream cache single. If you were following along and you've brought all that data, that command is right there in the chat. Feel free to run that alongside. So here, as you can see, when we ran that quick start batch script, you're going to have basically the output from converter. Notice it's going to go through that CATIA part. It's going to analyze some of the information about it. And then it's going to go ahead and it's going to give us that stream cache single file that we asked for right here in our current working directory. You can declare like an output directory for it, but for now, we're just doing everything local here. So there's the stream cache single file. If I believe next, we want to look at creating a stream cache directory, and we can see how those two differ. So really the only difference is we're asking it to output the SC instead of the SCS, and then we're giving it the name of the directory we would like it to create. This does not have to exist already. So here is the cheat command for this. Maybe. My meeting controls show up again. There we go. Alrighty, so if we go ahead and we do this conversion, I realize Zoom chat does not format it too well, so I apologize. But we will see it will do that same thing. It will analyze the model the same way. And now if we look out in our quick start, we can see our support bar stream cache directory that we've just created, going and looking at what the stream cache directory contains. You'll see kind of these weird, nondescript names for the files. And so that combination of files are going to be what's going to allow us to stream this data as opposed to just loading it straight in. So that was an SC directory. As I said, an SCZ file is essentially just the contents of this directory zipped up into a single file. So if we look at how we're going to do that, there's a couple more commands. We're still going to declare the output SC the same, but all we're going to do is we're going to flip on the SC create SCZ flag. Note that there is another flag here for compression. So let's go ahead and let's create both a compressed and an uncompressed SCZ file, and then take a look at the differences between those. So pulling up my cheat sheet again, let's go ahead and do the uncompressed first. This one's going in the chat as well. Let's go ahead and create an uncompressed stream cache zip file. Boom, easy. So now same thing, we go out here and we can see in our quick start directory, we see the uncompressed SCZ that we just created. Note that I am asking for all these file names it's giving us. So now if we want to, man, the Zoom window is in my way, I'm sorry. So now in order to compress this, I'm just going to run the same command we did before, but I'm gonna flip the false compression flag to true and change the name of the file because it will not overwrite it. And bada boom, we now have a stream cache single file. We have our SC directory, and we have both a compressed and an uncompressed SCZ file. So, looking at the difference between the compressed and the uncompressed, I mean, obviously it's going to be a little bit smaller, but you'll notice that all of these kind of have varying file sizes and varying pros and cons. So now let's maybe take a look at actually visualizing those files that we just created and seeing what they look like. In order to make these available, we need to move these into a new location. So I am going to grab all of these files and I'm going to go down into converted models, user SC models. This is where our quick conversion was from before, and we'll drop them all in here. And once the files exist there, we should be able to go back into our browser and actually view these. So we're not going to view the stream cache single file, right? Because that's not a streamable file. And right now we are using the streaming solution. So let's go ahead and let's take a look at that stream cache directory that we created. And you'll see that this same file that we converted before is going to come right in, easy peasy. So that's using a stream cache directory. And now for our stream cache zips, we should be able to look at our uncompressed stream cache zip. Easy, looks good to me, as well as our compressed one. Boom. So all these different file types and all these different conversions, ultimately once they are converted, are treated the same by everything on the front end. So there's really no difference. It's mainly, what is the right solution for you? Is network bandwidth an issue? Is, constantly compressing and uncompressing an issue? So just kind of what solves your issues, or solves your problems, excuse me. So we've basically taken a look now at creating all of the different kinds of stream cache files. And that's great, but there's a lot more to conversion than just the file format that you want. There's a lot of customization that you can do as you're kind of going through that conversion, as far as what information do you want to export with that? Do you want to export more data? Is your memory footprint an issue? Do you want to make your model smaller so that it can stream easier? Right, so there's all these different flags you can kind of use. If you want to export your PMI, or you have BREP data and you want to export that in the form of like being able to perform measurements in the Hoops web viewer, you can explicitly ask that to be exported. If you just want a small model, you can explicitly ask that none of that is exported. So let's maybe take a look at what using these flags actually does for us, in the sense of this support bar. All this text has been showing up because this is a model that has PMI data with it. PMI, product manufacturing information, is great because, it tells you everything that you need about making a part. Well, maybe when you ship this to your clients, you don't want to give away your intellectual property and show them exactly how you manufacture your parts. So what can we do to prevent that? And going back to the cheat sheet, it is possible to basically strip the PMI or whatever data you do not want. Once again, the chat is still here with me. I'm going to put this one in there, and I'm going to run it over here. So really the only difference, if we're looking through this command, we're still creating a compressed SCZ file. The only difference is we're throwing on the SC export PMI false. So if I was to run this, we get the converted file. It should be in the quick start. No PMI, look at that. I need to move it down into the SC models. And now if we go and we take a look at that converted model, that was compressed, we should all of a sudden see that text that was appearing before is gone, because basically this model, when it was converted, that data was removed from it. If we compare the PMI to the non-PMI model down here, apologize, my windows are getting a little bit messy. We can see that stripping the PMI took the file from 120 kilobytes compressed to 56 kilobytes compressed. So, over 50% of the size of that file is PMI. That's going to make it a lot quicker and faster to stream. Maybe not at this file size, but when you're getting into the hundreds of megabytes, if not gigabytes, that's going to make a difference. So some of the other cool factors or things like I was talking about here, being able to kind of like decrease and increase the memory consumption, or decrease and increase the functionality of your model. So if we go in here, this is a good example for this one. You can kind of see the geometry on these curves on the end are pretty smooth. They're good, I like them. But say you're running this on a, maybe a machine that doesn't have like a nice GPU or something like that, and you need to dumb this model down a little bit for that machine. Hoops Converter is going to make that very easy for you to do without changing your original model. You'll note here that there is this tessellation quality flag. It goes on a scale from 0 to 4, so 0 extra low, 1 low, medium, high, extra high. So if we want to maybe see what it looks like to have this with a lower tessellation quality, we can do so very easily. This is the same command we've been running. We're creating a compressed SCZ, asking for the output name, but we're going to be specifying the tessellation quality for this to be absolutely as low as possible. So I'm going to go ahead, I'm going to create this model. Converts just as it has before, conversion successful. I'm going to go back out to the quick start and grab it. Here you can see this is the one we just created. Let's drop this in here so that we can actually load it. So I'm going to pull these up side by side. So so on the left we have, this is the normal one as was created. Let's go look at that one. I need to be reminded of it. Compressed Tesla. So now we can see that converter was able to, so I think, yeah, you can see the difference there. So converter is able to, on the fly, look at that CATIA file, say, okay, you want to, decrease the footprint from this, or you want to decrease the tessellation quality. Boom, there you go. It's done. On the flip side of that, it is possible to also increase the tessellation quality. So if we run this same command, but we flip it to 4 instead of a 0, and also rename the file that we're writing to, and as well as drag it into the right directory. When we pull these up side by side, you can see that you can decrease quality. Oh, that's not a right name. But you can also increase the quality of it. So here, looking at this circle, you'll notice over here on the left, it's a little bit jagged. You can kind of see those triangles. Boom, that looks very good. So obviously, going back and looking at these models, you're probably going to have a varying footprint for these. Yeah, so 70 kilobyte difference between a low and a high tessellation. So you have that ability to kind of customize this as you're converting to your needs.
I think, so that's, Tony, that's really important to mention, since you're focusing on data translation, but you can drive that experience through the web viewer, kind of swapping between different levels of detail. So there's a number, we're focusing on translation today, but that usability through the web viewer, that's a whole other class, but allows you to leverage those different translation values.
Yeah, definitely.
Sorry to interrupt, but
no. Thank you for butting in. I appreciate it. So as he was saying, that's kind of its own can of worms, but you can see just kind of some of the cool functionality that Converter gives you out of the box. You don't really need to mess with your models that much. Converter can do some of that for you. So we talked about the different file types, right? We had our stream cache single, we had our stream cache directory, and we've had our stream cache zip files. We talked about how we can kind of change what data is going from the original model into those, changing things like stripping PMI data, taking out all of the predefined views, just leaving in geometry, increasing tessellation. You can do things like discard surface normals if you don't need those, to kind of greatly reduce the memory footprint. So that's all great and well. You've been able to, so we've covered converting to file types. We've covered how to kind of selectively put data into those file types. But one of the other things that Converter and Communicator offers are different workflows with working with your file types. So there's kind of two categories of working with your stream cache files. The first workflow is going to be a monolithic workflow. And this is just going to be kind of that SCZ, stream cache directory, surface level workflow. You're taking a single CAD model and you're running that through Converter, and you're placing that in a single converted location. This is going to contain all the PMI, all the matrices, all the materials, everything about your model. But for maybe people that are in a little bit more of an advanced CAD workflow and are working with like a CAD assembly, I guess this would be pretty applicable to people in the world of like product lifecycle management, or maybe people working on designing things at bigger companies or whatever. We do offer what is called a shattered workflow. And a shattered workflow is basically what it sounds like. It's going to take your CAD assembly as you run it through Converter, and it's going to individually convert all of the subcomponents or subassemblies of that greater model, and it will convert them individually. Now, there's a couple advantages to doing this. Talk about those in a little bit. The main ones are usability and performance, but let's take a look at what it takes to create a shattered model. So I had you guys, whoever was following along, was going to use, I had you copy over the Modo. So if we go look at this Modo, we can see that in here, okay, we have an assembly file, and then we have all of these subcomponents, excuse me, of this model. So we need to basically prepare this shattered model with this converter, these two converter arguments. And what we're going to do is we're basically going to say, hey, converter, I need you to parse through this model and identify all the different components. And then I need you to convert those into a directory of my choosing. So I'm going back to my cheat sheet here, and I'm going to grab my command. Again, I will, geez, I apologize, folks. Okay, the chat is coming. This is all for you, Paul. There we go. Come on, Zoom. Alrighty. Here is the, I apologize. Okay, there's the command for creating the shattered assembly. I'm going to go ahead and I'm going to run this. If we want to look over the arguments really quick, we can see that it's essentially similar to creating that SCZ. We're providing the same arguments, and we're basically asking Converter to go through this assembly and convert each component in it to its own SCZ file. We're specifying where we would like it to dump those. And we're also asking it to make a XML file that will show us sort of the relations between all of those individual components. So doing this in real time, I believe this is a little bit bigger of a model, so it could take a little bit longer, but I would like to pull up the conversion location and kind of see this as it goes. So right now it's looking through the model, trying to analyze it. That is done. It's still chugging along. We are dealing with, just in case you have a comparable data set that you're wondering, this is a 52 megabyte file right here, a little bit bigger than the 70 kilobyte support arm. But this will be finishing up any second here. Paul, just curious, are you using the same models as I am? That looks like maybe a license issue to me, but I think maybe Jonathan can help you out there.
Yeah, I'll see what I can do.
I apologize, Paul. So coming back here, we can see that conversion was successful. It's gone through. So let's see what these output files have turned into. I declared in my command that I would like it to prepare the shattered parts and converted model user SC models. So if I go down there, we will see here the Modo shatter directory. and boom, what we have is we have all of the parts from that original assembly, but converted to compressed stream cache zip files. So this is all great. We've basically taken our assembly and we've shattered it down and we've converted the individual pieces. Now the next step of the shattered workflow is to reassemble those shattered converted pieces into a master model that can then be referenced for visualization and streaming. So one of the things I will note here, in that this is a two-step process, with most of the computational work being done to compress all of those subcomponents. The advantages of this are that, say you're working on, you know, something with 25 different components and you change one of those components, all that you have to do is reconvert that one small subcomponent and then reassemble the master model. You don't actually have to go through and perform this conversion on everything all the time. So you can save yourself a couple cycles there. You'll see that to create the shattered model, we're basically taking the directory that we created in step 1, that Moto shatter directory that I just showed you, and then we're taking the XML from step 1 as well. Before we actually go through this, let's take a peek at what that XML actually is. This XML that is generated by Converter is essentially the assembly tree. So this is going to show you, as modeled in the original model, all of the components, all of the relations between those components, excuse me, and the location to those converted parts. So you can see in here that, you know, some components have a lot of children, some obviously don't, blah, blah, blah. So by modifying this XML file for this next command, you can create how things get rebuilt. So say you have, you know, say on this motorcycle that I have here, you have like 3 different types of tires. You can basically convert those all at once and have those all there. And in order to re-render this motorcycle with a new tire, all you have to do is modify that XML and then recreate it, which is basically links everything together differently. So you're not actually reconverting the entire model. You're just changing the little aspects that you want as you go along. So in order to do this last reassembly of the shattered model, I would like to go ahead and run this command. Maybe if my clipboard works. So I'd like to note that the runtime on the second command is significantly faster than that first one. Like I was saying, that's because we basically preload all of the conversion into that front step so that you can reconvert that master model at any point to change that overall shattered model. So if we go and we look at what we've done, we basically, in our quick start, we now have our Moto master directory that in here is going to be, so this is a stream cache directory, and all of the data in here is basically symbolic links to that model down in the converted models that we shattered. So note that if you're going to convert these and move things around, you need to move them relatively to one another. So now if we actually want to go look at this, there we go. If we want to go look at this motorcycle, we can do so. It's a little bit bigger, so it will take a second. So here is that shattered model. To kind of just show how all of these things are broken down and are their own individual pieces. Say we wanted to go into all those converted things that we did here in the Moto shatter. So say we wanted to look for the seat and say we just took out the seat, we just deleted that and refresh this model, we'll see that we'll still be able to stream in everything else. It might give us a little bit of a complaint about the seat, and yes, there is no seat, but right, everything else is there. So that's not so much like a, hey, it's robust if your data goes missing, but it's just kind of to show you how everything is linked together individually. And it's not necessarily like removing one part doesn't corrupt everything. So that shattered workflow is going to be, like I said, it's going to target like CAD assemblies, and it's going to be a very well-designed workflow for working with those. And what it's really going to do is it's going to allow you to like plug and play different parts into your model. It's going to allow you to, say you're versioning parts within your model and you need to swap out different versions of a part. You're going to be able to do that without having to reconvert the entire model every time. So that's kind of a big thing. I don't know, Jonathan, if there's anything else you would like to say towards like the XML assembly. I think that's another one of those things that's very powerful and is almost its own. There's a lot of depth to there. So if there's functionality you need there, we're happy to advise whenever. We've talked a lot today about the stream cache format. So I would hate to not mention the fact that Hoops Communicator allows you to author stream cache data directly. So you do not necessarily need to bring in data from another format. There is a Java and C++ API that will allow you to create stream cache models directly from your program. You can create new data. You can load existing data in through this programmatically as well. And there's support for all the different kind of modeling things that you would expect, like materials, views, matrices, whatever. There are some examples of that authoring code down in the authoring libsc examples location, but that is kind of its own can of worms as well. So we will not be jumping into that today. I would like to point out that the virtual training series are going to continue next week and the week after. We touched on the data translation today. Next week's CAD model traversal might be a very good follow-up to this. And then the operators in Hoops Communicator is going to be a very good class to attend if you're looking at, okay, I'm familiar with data translation and data visualization, but how do I get my own custom business logic into this application? So I realize we kind of blasted through there at the end, but those are the slides and the demos that I had prepared for today. I would be more than happy to go back and walk through those in more detail if somebody missed something, or now would be a good time to answer any questions in the chat. Can we load the file in JSON format instead of XML format? I do not believe that that is explicitly supported. It is not explicitly supported, but there's always a way. I mean, you can easily convert JSON to XML. It's kind of an extra step, but if you're more familiar working with JSON, I think you could hack that in there. I don't know if that's anything that would be officially recommended by anybody here at TechSoft 3D. But yes, of course. That's about all I am seeing there. I think that's everything that we have planned for you. I'd like to thank everybody for attending today. Feel free to reach out to me directly if you have any questions, Jonathan, or go to Docs TechSoft 3D. We have all the Hoops Communicator stuff there. There's more information on Converter. That's where all those command line arguments and stuff came from. I'm happy to stick around a little bit longer. Paul, I know you had some issues, so I'd be happy to troubleshoot those with you now. Everybody else can feel free to hang around if they would like. But if not, we appreciate you being here.